Okay, good evening, students. I give you a warm welcome in year 2021. We are ready, we are determined, and we are working hard. And every day we are using, not wasting our time. Is it true or still some doubt is there?
No, sir.
Okay, students, that is our commitment. It is very important that we work every day, and that consistency is the secret of the success, students. The successful people are very regular in their work, students. If they are irregular, they are out. So we have to work each and every day, student. That's what we mean, that we should be continuity in our work, students.
Yes, sir.
Okay, we are coming today with a very important topic, students, which is most important topic now is on the screen, students, solid state. I think you are familiar with the solids around you.
Yes, sir.
And are all the solids same which you see around you, students?
No, sir.
Basically, you are able to experience three states of the matter.
Yes, sir.
And there is one more state which is
Plasma.
experienced at very high temperatures in the stars, students. So what we basically know around me, so many solids. Do all the solids have same properties, students?
No, sir.
Do they have the same type of conductivity, thermal properties, or hardness,
No, sir.
or elasticity, whatever properties you want to see, students? They are the solid, students, and you see that the solids have got wide type of properties. See, even the cup of tea which I am taking is a solid, student, in which I am taking tea, and there are different types of solids around us. Even I have used a solid pan, tea to make the tea, students. That could under withstand very high temperature, students. And you have electrical wire, students, which are very malleable type of solids which can be turned into wires. And the building material, you see, students, aluminium, so much of that is being used. So the important point is your laptops are also a type made up of different type of solids, your mobiles, everything. But we know that different solids have different properties, and that is an important point, student. Different solids, what type of properties you are talking about? As I said, there are so many type of properties: thermal, electrical, strength. Uh, Now the question is, students, some solids can withstand very high temperature, students. They have got certain magnetic properties, you are saying. They are used for packaging material, they are in the polymer form, students. Now, what is it that makes different solids different? So the question comes like that. What I am trying to tell you, students, that to me, chemistry is science. Chemistry is science, students. That means there is a science behind everything. We have to understand, student, why should the property of one solid be different from others? Can you tell me, students, what is your answer of the science behind the solids? Tell me.
Sir, the properties in different solids are different due to the difference in the nature of particles.
Hmm.
Then difference in the type of bonds which are formed between the particles,
Okay,
like hydrogen bond, van der
okay,
Waals bond, etc.
very good, very good, very good. Your imagination is good. You see, life is all about imagination. Science is also based on imagination. We will in solid state there will be a lot of imagination, student, lot of visualization, which we can't see three-dimensional structures of crystals. How we will do visualization? And when we can't do the visualization, I will give some students short tricks to remember those things, because it may not be possible in the solid state to show everything very clearly, because it involves a lot of visualization, students, and three-dimensional pictures may not be easy to show. So whatever will be possible, we will try our best, students. So what we are saying, the different solids have made up of different constituent particles. different constituent particles. ठीक है?
Yes, sir.
Okay. What are these particles, student? Atoms, whatever you have, the atoms, ions, or different elements which form these atoms or ions, or it could be molecules also. Molecules also. So there are different types of particles, and these different particles will have different properties. Second, what else is there, students? Even if the particles are same, students, there is a binding forces, student, between the particles. What are
Yes,
their
sir.
binding forces? What do we say? That there are interactions. There are interactions, students. What type of interactions are there between the particles? There are attractive interactions, there are repulsive so many types of interactions are there between the particles. So these binding forces which are binding these particles, students, which are operating between the constituent particles, they are also different. You have studied some part of it already in the chemistry: covalent bond, ionic bond, then various type of uh, van der Waals attractive forces, London dispersion forces, polar bonds, hydrogen bond, as you said. All this will be a part of the study of the solid state. Okay, now there are these things are there. There is another important thing, student, that there is a attractive forces, or there is a binding force, student. And what else is there which will make a difference from solid to liquid, or liquid to gas? Students, what is that? At the ordinary condition, which we are saying room temperature, student, certain substances, most of the substances are solid which you experience, and there are only few gases: oxygen, nitrogen, some noble gases you are saying. And liquid, you know what type of liquids are there in the elements, which element is existing in the liquid form. You know what is that? You are aware of that? Liquid bromine, what they say?
Uh, Mercury,
Liquid bromine, and mostly
bromine.
stuff is solid, and chlorine is gas, fluorine is gas, you are saying. So students, what we experience, the important thing is what we call as thermal energy. Very important. As the thermal energy, what is everything has energy, students, energy. As you increase the temperature, what happens to the thermal energy? It is increasing. The particles are binding by a force, attractive force, and you put energy, thermal energy, what will happen? So there are two things which are operating opposite to each other: thermal energy. And if attractive force is weak, thermal energy is more, what will happen? The particles will move away from each other, and you are getting, you see, gases. We are saying the forces of attraction between the gases are almost negligible. That is what we say, assume, students. And the liquid, the forces are more as compared to gases, and in solid the particles are very closely packed, students. The distance
Yes,
between the
sir.
particle is very small, and the attractive force is very strong. That is what we say. Right or
Yes,
wrong?
sir. Yes,
Okay,
sir.
student. So we are coming to the science behind the solid, liquid, or gases. All right, here is a small thing. You see that we are saying these are the constituent particles which we are showing by sphere, students, spheres. And you can see molecules that make up the solid in regular repeating pattern. They are firmly held in place, but they can still vibrate. They are still vibrating. There is some energy is already there, student. There is a vibration, but that vibration doesn't allow one particle to move from one to other position. Liquids, molecules that make up a liquid flow easily. As we say that, students, you have solids and you are saying fluids. You know which are fluids? Which can flow?
Flow.
Flow. What flows, student? Liquid flows. Gases flow. But different liquids have different amount of the flow, which you will see viscosity or how much readily liquids can flow. But gases, you know how fast they fly away. So some amount of attractive force is there in the liquid still, you see, which is tying up these molecules, and they are kept from flying apart from the forces between them. Liquid assume the shape of the container, you know, student. And gas molecules, they fly in all directions at great speeds. They are moving randomly, students, and they have very weak attractive forces, we say negligible, and therefore they can move apart. The plasma, these are at very high temperature of stars. Atoms lose their electrons. The mixture of electrons and nuclei, that result is the plasma state of the matter. That is not our contest here. Okay, students, so we have got some idea about why the, now the question will be, why do we want to study solids? Why do we study solid, student? Every time there is a question for what we do. And I say that every time we will talk of science. Why do we study solids? Because solids have different properties, and I need different solids of different properties in my everyday life, student. Therefore, I will be always searching for solids of definite thermal properties, conductivities, hardness, different type of requirements which I have, students, or certain packaging material you need, biodegradable material you need, surgical materials you need, all types of things will require solids. Therefore, there is a need to study what we want to study. Question. Then question two, you will say, what you will study in solid? What you will study in solid? Tell me, what you will study in solid, student? What we will study? So what is the interest, what we want to study? The structure of the solid, student, is very important. Structure. Or you are saying diamond and graphite are made up of the carbon, but still the properties are very much different. Diamond is the hardest substance known, and graphite is having uh, soft and even used in electrodes as conductors. Now they are carbon, both are carbon. So what is the difference, student? What is the difference between different solids? Why they are becoming different? The structures, students, are important, students. Though so different particles give rise to different type of structures. And when the structures of the solids are different, student, what happens? Their properties will change.
Okay,
Therefore,
sir.
it will be of our interest to study the structures of different solids, whatever will be possible. And once we understand the structure, we know how we can modify the properties of the solid, students. If I change the structure, what will happen? So this is the reason that it becomes important to study the solids. So, and what type of particles are there, whether what type of arrangement is there in the particles, what type of crystal lattices will be there, which will be discussed. Okay. All right. The first idea we have, students. Therefore, in this chapter, our interest is only solids. Because liquid and gases you will be studying in states of matter, and here we are studying, focusing on the solid state. So naturally, when you study anything, first thing is what are the general characteristics of the solid state, students, which are different from the liquids and gases. Can you give me few, one, two, three, students? What are the general characteristics? What are the general characteristics of solid states? What do you
Sir,
see? Solids. Here we have shown a picture, actually how the solid particles are packed very closely. As you can see, student, three-dimensional picture of the solid particles which make up. You know that they have a definite mass, volume and shape. The shapes of the solid is not changing as they are lying before you, students. Intermolecular distances, as you can see, the packing is so close, student. Intermolecular distances are short, forces are strong. Their constituent particles could be atoms, molecules, ions. They are having fixed positions. It is this particle is here, it is not going here, but they are oscillating about their main position. And incompressible, you know about that. Incompressible,
yes, sir.
rigid, and the important point is the strong intermolecular forces and
Forces of
short
attraction.
distances. Distances are very short between these particles, as you can see. The center of this distance is short. The forces are very, very also strong. So this is important point, students, that what are the general characteristics of these solids. So we are learning the science of the solid, students. Okay, we proceed further, students. Actually, we will find that the solids can be divided in two types of the solid, students. They can be, this is what we say, classification of the solids. In chemistry classification, we do a lot of, student, because it helps in study of the subject. Classification, one are called crystalline solid, students. Crystalline solids. Others we are saying amorphous solids, student. Amorphous solids. Can you tell me, student, you have any idea about the crystalline and amorphous solid, students? What is the difference between the crystalline and amorphous solids? What is the
Yes, sir.
difference between crystalline and amorphous solids? You see that? You say this is a crystal. What crystal you have seen? Tell me. You say diamond is very, very
Diamond,
crystalline. The salt which you, sodium chloride is, you are
sodium
saying
chloride
crystalline in
crystal.
nature, student. Then certain other things you are saying. Quartz, you see, this is a crystalline example, student. And amorphous or rubber, you are saying rubber, you are saying a form of the rubber, student. Rubbers, what is that? You are saying, oh, it looks like amorphous, student, amorphous, students. Now the question is basically, what is the difference in the structure or the arrangement of the particles in the two, students? What they are consisting of, there are particles in them, atoms, ions, or molecules. Now the question is, students, how these particles are arranged. What we want to talk is the arrangement of constituent particles, students. And on the paper, how will I show the particles, student? I will use some points to show the particles or the atoms or the molecules, students. The crystal, student, the arrangement of constituent particle is ordered.
Okay.
What I am saying? Ordered, student, ORDE, ordered arrangement of what? Constituent particles. You are saying there is a regular pattern, student, of the arrangement of the particles. It repeats, student, periodically over the entire crystal. ठीक है? Or what we say, student, it has a long
Yes, sir.
range order. This is what we call as
Okay.
long range order
Okay, sir.
of the particles. Long range order is there in the crystal, student. If I say this is a particle, then I will say okay. So you can see there are, if there are particles are periodically repeating, students, they can be of two different types. This is different, supposing this is different. So what we are finding,
Okay.
student, there's a repeated pattern, and this order will continue.
Okay.
Long range, long range, student. For example, here rock salt, you see rock salt, which is made up of the constituent particle. You can see that the particles are arranged, student. There is a regular repeating pattern of the particles, regular repeating pattern of the particle. You can see, and this will extend to long range, student, long range arrangement of the particles, you can see. This is a
Okay.
crystalline solid, which is a rock salt. How do you determine that? Experimentally, we can determine by X-rays and other methods the structures of these crystals. Whereas amorphous solid, you are saying plastics,
Rubber.
glass, rubber. There is no regular repeated long range order students. They have, you will see crystals, they have regular shape. They have regular shape students. And in this case, there is no long range
Irregular shape.
orders. The particles are arranged student in irregular fashion, and these type of solids, atoms, ions, and molecules only have short range order. What do they call it? Short
Short range order.
range order. Okay. And here is a glass student. As you see the particles now, they are distributed in a very random fashion. In a very random fashion, student. It is just like this. You see,
Okay.
in a cinema hall, you see the chairs are arranged in a very regular pattern. See, you know the rows in the chairs,
Yes, sir.
A1, A2, A3, like this. There is a numbering. But if you are attending some mela, marriage party, or some function, or
Irregularly arranged here and
students or
there.
people are protesting all over the world in thousands, or do you see any regular arrangement of them? They are just moving around in a very random manner there.
Yes, sir.
So students, here we are going to mainly study, in our case, the crystal structures. Our main objective will be the study of the crystal structure, students, which have got repeated regular pattern and long range order. The particles will be arranged in a long range order, students.
Order. Okay.
All right, so we understood this part also. Some of the examples what we see, students, examples are given to help us. As I say that, students, when we give you lectures, or when you say these are the rules on the basis of which we will name these compounds, students, but when we solve questions, student, then it becomes more better to we understand better, because we can't remember so many things. It is difficult.
Yes, sir.
Similarly, we explain to you, but if we show examples to you, then it becomes more easy
More clear. Okay.
to understand. See the table salt which you are using at home. This is crystalline, in which you see the particles have definite arrangement, students. And amorphous solids, you see those cotton candies or ice cream cups filled. You can see that here. These are ice cream filled. These are amorphous, student. And particle, see how they have become random. They have become random in this. तो कॉटन कैंडी वो जो गोला सा बच्चे खाते हैं वो फूला सा ऐसे लगता
Yes,
है,
sir.
तो
Yes, sir.
आप यू कैन सी दैट दे आर इन द amorphous solid form, students. Now the question is, students, there is one question likely coming, whether in objective form or in some other form, because a
Okay.
lot of questions will be in the objective form this year. The distinction between crystalline and amorphous solid. This always is there. There are certain properties, students, which we should understand. So, one, I have a crystalline, students, solids, and other I have amorphous solid, students, where the differences are there. Properties, first, if I discuss the shape, student, tell me which will have a definite shape.
Crystalline substance.
So crystalline substance, student, they have definite geometry, because the particles are arranged in regular repeating way, long range, whereas in amorphous there will be irregular shape.
Irregular shape.
If you take rubber or anything, what happens, you know. The melting point difference is important. It has been asked in the paper also, student. Can you tell me what will be the difference in melting point of crystalline solids and amorphous?
Uh, so crystalline solids have sharp melting points, and amorphous do not have sharp melting points. They melt over a range of temperatures.
Now the
Like
question is,
first they will
this
soften
is the
and
point,
then
sharp and range melting point. Now the question is, what is the meaning of sharp? That if the solid, what is the melting point? What is the melting point? The temperature at which the solid
it's converted
becomes
into liquid.
converted into liquid at the atmospheric pressure.
Pressure.
There is an equilibrium between solid and the liquid. That temperature is called the melting point.
Yes, sir.
Why it will have a sharp melting point, students?
Because it will abruptly melt at a particular temperature.
Why?
It
That
will
is
just
the question, student. That is what we are saying. Why it will have?
so because it have regular pattern of arrangement of particles, so the
So
bonds
there
will
is
break
a
abruptly.
ordered arrangement of particles, which you said long range. All the particles. Therefore, students, there are forces which are binding these particles. The arrangement is ordered. Therefore, the forces are almost all same. So, at one temperature, all of these will break. They will absorb the same amount of heat, student, and therefore, what will be the result? They will melt at one temperature. But here, what will happen, student? There is no ordered arrangement of the particles. Therefore, the binding forces are also non-uniform. So, some part of it may melt faster, some may melt slower. The result will be that it starts melting, supposing at 40, and then it goes up to 60 or so. So, what will happen? There is a different arrangement of particles at different points, students, and different binding forces are there at different points. The result will be there will be a range melting point. Okay, this question has been.
Okay, sir.
Every question, sometimes using question look easy, but anything can be asked. Next is the cleavage property, students. What do you mean by cleavage, students? With a knife, you supposing you cleave it, then what will be the result? If you cut with sharp edged tool, student, there will be two pieces.
Two pieces.
What type of surfaces will be generated, student?
Sir, either the surface can be plain or it can be irregular. For
So
crystalline, it is smooth, and for amorphous, it is irregular.
there will be plane surfaces, irregular surfaces. Again, the reason we have to give. The answer is again basically the arrangement of the constituent particle, which we are saying again and again, student. That there is a regular repeated pattern, long range order. Here there is no such order. So far, so good. I thank you for interacting and answering the question. It is very important, student, to participate and interact. And the energy levels are then higher, or the energy levels will drop, then both of us will sink. The next is the heat of fusion, student. What is heat of fusion? Heat of fusion. What is heat of fusion? You have heard about delta H, delta H F, student. What is that? Enthalpy of fusion. What did we define enthalpy of fusion, students, in chemistry?
Sir, enthalpy of fusion is the heat
What
change
happens?
when a solid is converted into liquid.
So at the melting point, solid starts getting converted into the liquid. At that time, the temperature does not rise. Why? The temperature does not rise. You have read it. You know, at one point, solid is heated, temperature is rising. At one point, it starts melting, temperature stops rising. Where the heat goes, that is
Uh,
a latent heat, which we call
Latent
an
heat of
enthalpy
fusion.
of fusion, because
Yeah.
the forces which are holding the particles, they use it, they need it in order to break apart, so the temperature doesn't rise till the whole of the solid has melted. When it all becomes liquid, then further temperature shoots up, student. So what will happen to the enthalpy of fusion, student? In this case, will it be definite value or not a definite value? That is the
So
question.
for crystalline, it will be definite value.
Definite value, students. This is a very important question because the particles are having repeated regular arrangement, similar forces at every point, student. The binding forces are same, uniformly distributed. So the enthalpy of fusion will be a definite value. All these particles will break at the same time. But here, their different particles are at different location, are arranged in a different way. Therefore, the enthalpy of fusion, they do not have student definite value
Enthalpy of
of
fusion.
enthalpy of fusion, students. Clear?
Okay.
This property has been asked 10 times in the paper now. What is this anisotropy, students? What is isotropy? Iso means what in chemistry we told?
Same.
Same. What properties you are studying? You take a crystal and study some properties like refractive index or thermal properties, students, from different directions. From different directions, what happens? You are studying electrical resistance or refractive index. What you are studying? You are studying some properties, students, like refractive index, or I am saying electrical resistance, students. Will, if I change the direction of the crystal, student, will it the values be same or different?
Sir, different.
In crystal we are saying is an isotropy. Crystal what line are an isotropic in nature. Question was there, why they are anisotropic in nature, students? If I study from different directions, what happens?
Different values of
These are coming,
properties.
why they are coming different? Because you are going to get different arrangement of these different, because crystal is not made up of one particle, there are different particles. So you go this side, you go this side, you go that side. What will happen? The arrangement of particles will become different, students, and the properties will change, will be different in different directions. Different values will be there in different directions. The properties of this will be different properties in different directions.
Directions.
Crystals are an isotropic, student, but here there is no regular pattern of the particles, student. They are mixed up. They are mixed up. There is nothing regular, so you can go any side. They are totally mixed up. So these are isotropic. They are isotropic, students. You can, their properties do not depend on the directions, because there is no Lagrange order, and this is there is a irregular arrangement of constituent particles in different directions. ठीक है? So
Yes, sir.
irregular along different directions. So what will be the result of that? There is irregular arrangement of particle students in all directions. So the result will be the amorphous solids will exhibit isotropic arrangement. ठीक है?
Yes, sir.
This is the important property. Nature order in arrangement of constituent particle. We already have told you this is a ordered long range,
Yes, a long range order and short range order.
short range student. One mark questions are put in many ways out of these. Out of these, we have to understand everything. In different books, you will see that they have tried to show the meaning of this because students were finding it difficult to understand. Student, crystalline solids are anisotropic because its
Okay.
question has been put up in many ways. Same properties like electrical show different values when measured along different direction. This arises from different arrangement of particles. You can see that this is a crystalline solid. These are one particle, this is another particle, one, another, this is. So if I move this side, you see, you are not getting any particle here. And if you move this side, what is happening? Different type of arrangement is there and different type of particles you are going to meet students when you go to different directions. If you go to
Yes, sir.
this direction, you see, you will meet different particles. And if you are going this way, what particles you are meeting? See, therefore, in anisotropy in the crystals. Crystals, important thing to remember, anisotropic. ठीक है?
Yes, sir.
Amorphous solids,
Isotropic.
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 This is the conclusion actually. Here question has been put on, nothing more than that. Because the reason if you ask amorphous solids are isotropic in nature because there is no long range order, no long range order. And arrangement is irregular along all directions. Therefore, value of any physical will be same along any direction. Okay, question answered. If we have to write the answer, we should know how to write an answer. For example, the questions have been coming on the screen, students. Why are solids rigid? What is your answer? 30 seconds.
Solids are rigid due to the fact that the constituent particles of uh, solid do not the constituent particles of solid uh, have fixed positions and can only oscillate about their mean positions.
Fixed position. Or they are very closely packed. You not mentioned the important point.
Okay.
You see, if they are loosely packed, what will happen? If something is loosely packed, you can compress it. They are packed as you see one, just they are touching each other. Did you see that? We showed you. So when the packing is very, very close, student, what will happen? Then they cannot get one particle cannot enter into another particle. Maximum it can touch. Got my point?
Yes, sir.
Array, one,
Yes,
there
sir.
are two things, two objects, student. Can they enter into one another? They can only touch maximum. So
Okay.
atoms are particles. Why do solids have definite volume? Why will they have definite volume? Why anything should have a definite volume, student? Definite volume will be there due to what, student? 30
Uh,
seconds. Because what is the reason? Why will they have definite volume, students?
because the particles in solids have fixed positions
They have very strong attractive forces,
and strong,
very
strong
closely packed.
intermolecular attractive forces.
So this is the reason. Why did we put questions to you? Because you may know the answer, but what you write, student, then it becomes all the important point. Answers are one word or one line. If we write something else, then that doesn't serve the purpose. We have to be specific in answering question. One word or one line answers are there, nothing more than that. The question number 3 on the screen, student, classify the following as amorphous or crystalline solids. Students, okay, polyurethane, what it will be?
Polyurethane, amorphous.
All the polymers, you can say that. Now the question is polymers are amorphous. ठीक है?
Yes, sir.
Amorphous. Okay. Polymers, you generally will say the polymers. What polymers? They will not have any definite arrangement. They will be amorphous. ठीक है?
Yes, sir.
Okay. Naphthalene.
Naphthalene will be crystalline.
Naphthalene is a solid, is a crystalline. Students see. What is benzoic acid?
Crystalline.
Crystalline. Okay. See. What is Teflon?
Teflon is amorphous.
Polymer, na? A.
Yes, sir.
Okay. Potassium nitrate.
Crystalline.
It is a ionic solid.
Yes, sir.
No, K plus NO3 minus. Crystalline. Okay. Cellophane.
Cellophane is amorphous.
They are polymers. Polyvinyl.
Amorphous.
Fiberglass.
Amorphous.
Copper.
Crystalline.
Okay. Sometimes small questions are given in the paper in objective type. And there also those who have not attempted question, they will be, in doubt. So our attempt is to solve as many questions as possible. Why is glass considered a supercooled liquid? What is a supercooled liquid, student? What we told you, liquids and gases, they are fluids.
Yes, sir.
They can flow. If something can flow, student, then it will become a liquid. And
Yes, sir.
glass, you know that the glass flows. Do you know glass flows, students? How it, glass flows? You have seen very old buildings and the window panes which are made up of glass. Glass window, student, they are thicker at the bottom and thinner at the top. Why? What happens? Glass windows. The sun rays are falling over years. Slowly and slowly, what happens? The glass flows down. And
Okay.
you will see that the bottom of them become thicker over a period of time. ठीक है? Got this question was there in one of the papers. So glass is a super liquid. Gas, student, it can flow. It can flow, as we have seen here. Refractive index of a solid is observed to have the same value along all the directions. Same along all the direction.
That means isotropic. It is a crystalline solid.
Huh? Crystalline?
No, isotropic is not crystalline. It is amorphous. Isotropic is amorphous.
I said you will not answer any question so fast. Amorphous, solid, okay. Would it show cleavage property, students? What is the second answer?
Uh,
What is the meaning of cleavage property? Will it give regular shape or no? It will show.
Irregular shape.
So what it will lead to, student? Irregular surfaces. The surfaces are irregular, so then it does not show the cleavage property. One mark questions are given, student, in the paper, and very, very small questions. Got the result of this?
Yes, sir.
So
Okay.
questions have been answered. Student, see, the point is that whatever we learn, we should learn it thoroughly. And we don't repeat the things then, because we know that after you learned it again, you are in trouble, students. Now we are coming to certain classifications of crystalline solids, student. Our main object is to study the crystalline solids, students. And you will see in a book, student, they have given a table of different types of the particles based on the nature of the forces which are holding these particles. For example, student, you have molecular and atomic, they will also come in this category, atomic solids. Molecules or atomic solids, student, where the constituent particles are either molecules or atoms. Molecules or atoms. Hydrogen exists as H2, oxygen is O2, you know, carbon dioxide is C2, CO2. So you say dry ice, what is dry ice? Made up of CO2 particles, students.
Yes, sir.
So here, student, what we are saying, the molecular or atomic solids are there, but there are different types of forces between atomic and molecular. The first type we will experience is, student, non-polar.
Okay.
Non-polar atomic or molecular solids. Non-polar means there is no charge on either atom. There is, then the atoms must be same. If atoms are same, there is no separation of charges. What force is there between them? This could be some noble gases, helium, neon, argon. If I say, student, they are monoatomic particles. Or you have certain molecule, students, which are non-polar. For example, if I write HCl, what happens, student? Is there any force between them? There is no charge. If I write CO2 also, what do you find here? This is a zero dipole moment. There is no
Yes, sir.
charge on either of this because they cancel each other. In such students, non-polar atomic or molecular forces, what type of forces are there? These are very, very weak forces. What forces we call? London dispersion. What is the name of the forces you have read it? London dispersion forces too.
London dispersion process.
Therefore, there is a very, very weak force between them, student, and they will be very soft. There is any free electrons here? Nothing. So what will happen? They will be insulators. The
Yes, sir.
properties will depend on that. There is no electron free insulator. There is no ion free. So, and their melting point will be low, students. So here we have shown it, non-polar dispersion like example, soft insulator, very low melting point. After this comes the next one, student, which will be polar. Polar means, student, the two atoms, if I say HCl, what is happening? You know that there is a dipole moment. This is more electronegative, student. Then here the interactions become what type? If I write sulfur dioxide, then you also know what we do in sulfur dioxide, student. This has a dipole. Okay, this side, what is happening? Students, you can see such molecules have, they are polar, they have a dipole moment. They have a dipole moment, students.
Yes, sir.
The result of that you already know, students. What is the result of that? So in this, the forces will be little stronger than this. What are those forces called? They are van der Waals,
Dipole
dipole
forces.
interactions. They will be very soft again, insulator, and also they were having very low melting point. Their melting point will be lower, but little more than this. Then the third form is hydrogen bonded, students. Hydrogen bonded. What happens when hydrogen bond is formed? This is also van der Waals, but it is a stronger force, as you will see in the case of H2O, student. H2O, you know, water forms hydrogen bond in ice. So this becomes, ice becomes hard. You see, ice becomes hard, student, because of the formation of hydrogen bond. There is no electron, nothing till insulators. Again, melting point is low. These are coming in atomic and molecular solids. The properties we have listed here. ठीक है?
Yes, sir.
No problem in this. What type of electrical properties? Their physical nature, their melting point, and with examples. Then ionic solids are the second part of that, student. Here the forces are electrostatic, and these are strong forces, student. You know that they are forming A plus, plus, and B minus. There are positive and negative. So there are ion, student. They will be hard and brittle. What do you mean by brittle, student? Because these ions are packed, students. When you put a hammer on them, what happens? They crack. There is a crack because the what happens? We will see in the crystal structure later on. They can slip. They can slip,
Okay.
students. Brittle substances will crack when you hit them because there is a layer of the particles which are arranged, student, in crystal in an ordered way, but that order becomes disordered when you hammer them or hit them. The result will be cracks will be produced. Understood? Brittle,
Okay.
because students don't know what
Okay.
is brittle. Cleavage means totally breaking. Brittle means there will be some crack coming because of some force which you apply on them, students. Because the arrangement becomes disturbed, student. Disturbed arrangement. So they are in the pure solid. There is no free ion. Unless there is a free ion, student, what happens? There is no conductivity. Conductivity is only when there are free ions. So when you put them in solution or when you put them in molten state, what will happen? They can conduct electricity. ठीक है?
Okay.
And because the forces are strong now, inter-attractive forces between positive and negative ions are strong, therefore their melting point will be high, student. This is important point. Somewhere question has been put. Examples, you know, NaCl, MgO, ZnS. These are some of the examples of the ionic solid. Any doubt till now, student?
No, sir.
Okay. Everything we study, student, from a science point of view, and we will decode each and every word written in the book. Because in objective type or resultive type of questions which are coming, they can become a question for you paper students. If you not missed anything, it's gone. See my point?
Yes, sir.
Okay. Are you with me?
Yes, sir.
All right, thank you very much that we are alive, we are not dead. I'm also keeping my energy high, or it makes a lot of hard work for me. I'm taking a very strong cup of tea with ginger before that, so that I keep my energy levels high. I put my efforts completely. I always tell you kindly, let this recorded videos be subscribed by more and more of your friends. Kindly share with them and give our contacts to them because every lecture is very much hardworking students. It needs 3 4 hours to make all these things. Not easy. Got my point?
Yes, sir.
This study is very hard and difficult. Not every, maybe you are taking coaching from so many teachers. Every teacher cannot do it. You will experience it. You'll find it very difficult. I mean, I from the morning to the night I am working for you people. Whole day my goes in this reading, studying, and sorting out the material, sorting out certain questions which can be asked in the paper. So our hard work will also be of should be of use to more and more students. That's my point. So at least you share with 5, 10 of your friends,
Yes, sir.
and they can subscribe our channel so that we our hard work is also not wasted. Metallic solid student, ionic solid, there are ions, and in solid they are not free, so they will not conduct in the solid. But when you put them in aqueous solution or molten or aqueous, then they will become free students, and they will become what? Conductors. Correct?
Yes, sir.
Science understood? Okay. Metallic solid, what is a metal? You are saying copper is a solid, gold is a solid, silver is a solid. So many metals you are talking about. Iron, copper, silver, magnesium, alkali, alkaline metals. Student, what happens? In metal, you are saying the electrons are loose. They are outermost electrons are loose. They are leaving the metal ions. So you have M plus and free electron, student. You can imagine a free electrons and metal ions. And then what can happen, student? There will be certain properties due to these free electrons. The energy heat can be transmitted faster, the current can be transmitted faster, student, because there are easy free electrons. They will carry on this energy, and thermal energy they will carry, the heat energy they will carry, student. They will carry the electric current also. And because there are metals and free electrons, and they become, student, malleable and ductile properties also they acquire, and metallic lusters they acquire. So they are conductors in solid as well as in molten state, student. Conductors in solid and
And molten state.
metallic solids, and their melting points will be higher depending on how much bonding strong intermetallic bond is. We have already discussed in inorganic chemistry these points. The metallic bonding, transition metal is still having stronger metallic bonding as compared to the alkali and alkaline, because more number of electrons were there for bonding in s and d orbitals. Okay? They become harder than those sodium and alkali and alkaline. So their melting point is fairly high. Conductors in solid as well as in molten state, student, hard, malleable and ductile. We are not written brittle here. You see the word brittle? Brittle means they will crack when you hit them, because the arrangement of the different layers becomes disordered. The last one we are coming, student, is the covalent network solids. A covalent bond is very strong. You should know about it. Covalent bond, student. Diamond, you are saying carbon carbon covalent bond. Four carbon carbon are forming covalent bonds in such cases, student. And the covalent bond is very strong, student. A lot of energy is required to break it. Covalent bonding. The forces is covalent bonding in diamond, in graphite, also in quartz, silicon carbide, student, aluminum nitride. So they will be very hard, students. If there are no free electrons, then why should they conduct? Except exceptions are always there. You said graphite is a conductor because that is the exception. We know about it. And their melting point will be very high. Diamond has a highest melting point, student. You are aware of this. Is it clear?
Yes, sir. Yes, sir.
So, students, in today's talk, we have discussed with you the solids. The key takeaway is what is what type of solids we have, student, amorphous and crystalline solids. What is the difference in the properties of the amorphous and crystalline solids? And the key takeaway is the different types of solids. When solids will be of different types, students, the constituent particles will have different types of attractive forces between them, students. Their properties will also change, students. That's what we are saying. So this was the first lecture. I thank you very much. Good night. I'll meet you in the next lecture. well, we will proceed further. It's a very good chapter. It's a very good topic because the applications of solids are very large. So you understood that very
Okay.
clearly. So we
Yes,
want
sir.
that this message should go to more and more students. So kindly help us in a way that our video lectures are given to more and more of your friends because it is very hardworking job, students, which we are doing almost free for all the students now. It's not, we are not taking much money or we don't have any funds basically. You can see that even every technology I use, I have to pay for it. Nothing is free. So whether we are using Zoom or whether using any board system, everything costs us money. So we are giving almost lectures free of cost to the students. So please help us so that its message goes to different and different students.
Yes, sir.
Lots of hard work is there in making one lecture, so you understand it. I thank you. Good night. Then we will see you in the next class. Okay.
Okay. Thank you, sir.
Namaste.
Thank you, sir.
Okay, students.